Hello, Maurits here. This will be a short video on how to use Ohm's laws and Kirchhoff's laws to resolve a circuit. Normally, of course, we should try to use Ohm's, parallel circuit law and series circuits law and so on to resolve circuits, but sometimes that doesn't work. Say we have this one. We will have cell here with a voltage of say 15 volts, and if I want to draw an arrow to indicate the direction of the voltage, so to speak, we draw an arrow towards the positive end, from negative to positive. Say we have then a resistor here. Let's give that, let's call that R1, and say it's 10 ohms. It's connected back again through another resistor, and say that resistor is call that R2, and say this is 20 ohms. And then so far so good. We could now resolve this using ordinary laws, right? These two are now in series. But suppose we put another resistor over here to follow the pattern. Let's call that R3, and say, to still follow the pattern, just say this is 30 ohms, and that will be connected to a cell over here with say 5.0 volts. And now we want to know all the voltages and currents through this. So let's call the voltage across this V1. If I want to put an arrow, which is rather good to do when we go through it later on, I put an arrow yet again from the negative to the positive end, and since this is connected to the positive end, it will be like that. Let's call this V2. Same thing, right? This is connected to negative end, positive ends, an arrow in that direction. And that means if you go, for example, from this corner to that corner, we will go either through 15 volts, something like this, or you go through 15 volt like that across the arrows. And let's just call this now V3, right? And then we have current going out from this one. Let's call that I1 because it goes through R1. We call this of course I3, and these two add up to become that current, that is I2. As you can see here, the current will go in the opposite direction across the voltage over the component, but in the same direction over a cell. Okay. Now first thing we can do is to establish how many unknowns we have. So, I'll write it here, unknowns. What is unknown? That is of course V1, V2 and V3, and I1, I2 and I3. So we have 6 unknowns. And that means in the end that we need 6 equations. We already kind of have 3 equations. That is the Ohm's laws, right? Or Ohm's law. And we have 3 of those, so to speak, working here. For each and every resistor, we have that the voltage equals the resistance times the current. So we can replace all the voltages with R times I, and we will use that a few times. Then by Kirchhoff's first law, we know that in this point we will add up I1 plus I2 equals to, I3 equals to I2, right? Let us say this is our first equation. Then what we will do is we will create two loops. So one going around here. And actually I won't create a complete loop. Instead what I will reason is that from this point to that point we have 15 volts. And that must be equal to the voltage over this, V1 plus the voltage over that, plus V2. This is our second equation. And then as a third equation, we now can make a loop around this, and we will get 5 volts equals to V3 plus V2, right? So voltage 3 over voltage 2, right? Not over, plus voltage 2. Okay, so this will now be 3 equations plus these that form 3 more, so we have 6 equations. We will actually use this one to create 2 new equations here, right? So what we'll do is write 15 equals to V1 is R1, that is 10 times I1, and V2 is now 20 times I2. And the same thing we can write here, 5 equals to this one, which would be 30 times I3, right, plus 20 times I2. We can continue a little bit here by making these look a bit nicer, but we don't necessarily need to. Anyhow, what we will do now is we have 3 equations, and I1, I2, and I3. And I will write them in a form that suits the calculator. So what we have is the first one, in the form we will want to have is our variable constant times our variable plus constant times variable and so on equals to constant in the end. So I will rewrite the first one as that. So say I1 plus, minus I2, subtract I2 there, minus I2 plus I3 equals to 0. And then we have the second one, which will be 10I1 plus 20I2 plus 0I3 equals to 15. And the third one being that 0I1 plus 20I2 plus 30I3 equals to 5. And that is our three equations. What we need now is to fetch our calculator, which I have somewhere over there. We fetch our calculator. We go to where do you have it? Equations. No, menu. Equations. Why? There. Equations. Simultaneous equations, and the number of unknowns is 3. And here we enter the values for our 3 equations. So remember now the x, y, and z is the I1, I2, and I3, and the an, bn, and so on are the constants in front of this. So the first one will be 1. Actually, I already have entered this one. Minus 1, and 1, and 0. The second one will then be 10, 20 and 0 and 15. And the third one will be 0, 20, 30 and 5. And then we press solve. And we will get a few voltages, or sorry, currents. So our first current I1 will be 0.5909 amps. The second current would be 0.4545 amps, and the third one here will be minus 0.136. The only problem I have with the last one is that we only have 3 significant figures, and I would like to have at least one more to calculate the voltage in the end. So if you look at the calculator, it says minus 3/22, and that is of course an exact value in this case. Actually it isn't, because there's a current and so on, but the calculator gives this value. Now we can use these 3 to calculate our voltages finally. V1, V2 and V3, right? So we go to our run mode, and now we calculate the first one is 10 times 0.5909. That will be 5.91 volts. The V2, that is the voltage across this one, will be 0.4545 times 20, so 9.09 volts. And the third one will be that one would be minus 0.1, actually no, we will use this one, minus 3/22 times 30 is minus 4.09 volts. And we also need to write these currents with 3 significant figures, or actually 2 if you look at the question here, right? So, but that is another thing. Let's just do the calculations, and then you can write them with 2 significant figures if you want to. One thing to note here, the current there is negative. That means that this current is actually going in that direction. Right, it goes in that direction. I will keep the arrow here since we write this as negative, but the current is actually going in that direction. And the voltage here is actually crossing that direction. This means actually that this here will now have a current into it. If that would be a cell, it will be charged, or if it's a non-chargeable cell, it will burn up after a while. So if you get a negative value, that means that you put your initial arrow in the wrong direction. And we can check that this works. We know that these 2 should be 15, and that seems reasonable, and we know that this plus that should be 5. That works fine. So this seems to be resolved. And now we have resolved the circuit using Ohm's law, Kirchhoff's law. We used Kirchhoff's first law there, the second law there, and then we used the tool in your calculator to find this. You could of course solve this system of equation using pure algebra, but this is for physics, not for math, so this is the fastest way to do it. I hope this helped a bit. Ciao.